Yes, ma'am. You can start.
Okay. So I welcome students and all for this lecture. Today's our expert is Dr. Doreen. She is the director of Computational Intelligence Research Foundation, and she has MSc BTech and MTech in the University Chennai, and PhD also in the University Chennai. And her research interests are parallel and digital computing, peer-to-peer computing, even cloud computing with data analysis also. And she worked in various institutions like Loyola and and she worked at Anna University also as a research associate, and she has more than 20 years of experience. She has worked about 30 papers in international and national journals, and she is a member of various organizations. And she is a reviewer for computer and electronic in the Unique Journal, which generation. Thank you. And we have a pleasure in welcoming her. And amidst her busy schedule, she is supporting us by giving her concern for connecting with this lecture. I thank you, ma'am, for coming. Already we have been met in the last year also,
Yes.
and you are continuing to support for us. Thank you, ma'am. Thank you. And I'm in charge to that.
Okay. Thank you, Dr. K. Vimala Devi, ma'am. On behalf of CIRF and Narayanan, sir. My screen, can you give me the opportunity to share my screen? Can you allow? So before my screen is getting shared, so I'm Dr. Doreen Robin, as introduced by Dr. K. Vimala Devi, ma'am. I've been into your university last time in person because of this pandemic, and this time we are all meeting you through online. So may I ask the questions? You can unmute and answer, or you can put your answers on the chat box. Which year do you belong to? Which year of computer science engineering students that you belong to? Can I get your responses in the chat? Or you can also unmute and speak. Hello, you're all there? May I get an answer from any one student, please? Yes, here's Ashil. You're in the third year. Yeah, good. So we are going to see the trends in grid and cloud computing. I know it is your final day of your class, and you are all happy and excited to complete your session this time. I think mostly this year semester, you had classes online or you had offline? Answers on chat. Quick chat, please. Thank you, Avinash. Thank you, Shashwant. This year you had classes through online or you had online. Thank you, Vinay. So this we never expected, but this pandemic has never affected our academics. So thank you, Ranjan. So today we are going to see about grid and cloud computing. I know you have been learning this for a semester. Before I start my topic, can you give me your answer? How are you all today? We have 53 people. Can you quickly give your answer in the chat box, please? My question is, how are you today? Good. Thank you, Harshal. Others, only one. We have more than 60 people. Yes, let me get answer fast. Thank you. Fine. Good. Great. Yes, everybody, just one word. Good, ma'am. Thank you. Thank you. Thank you, Varun. Safe and fine. Yeah, that's very important, right? To be safe. If I'm getting a response from you that you're all good, it gives me immense pleasure in this pandemic that it is because of God's grace and mercy. God has protected you. Thank you, Rutvik. So all of you are good. So today we are going to see about grid and cloud computing. Okay, so before coming into this field of basically I have my company which is called as cirf.co.in. Okay, so you can, after the session, you can visit my website. Okay, before I was teaching into engineering colleges for a decade, then I left the job, then I started this company called CIRS. CIRF, which stands for Computational Intelligence Research Foundation. Okay, so the website is cirf.co.in. Here we take students for interns. If you are good in technology, we have live projects that we allotted to you. Maybe in the end of the semester, some students they come, and the another stream is they come, get themselves trained, and then they take up the interns. If you are very good in your programming skill according to the requirements of the live projects, we are open to take interns for you. So always feel free to contact me. And this internship is a training. We provide training. This is going on now, and we also provide the full stream of all data science like grid, cloud, all technologies. We give training. Okay, basically I want to give you this because this opportunity, if you are good in Python programming, if you're good in the Django, or if you are good in very good web development, we have 2 openings in our company. Interns, we give you the project, you develop it and give it, you may be paid. Okay, so this is about my company. You can see it out, and this entire event I'm streaming it on YouTube. Okay, on my channel. I'm sharing the link on the Zoom chat. You can make a copy of it after the session. You could use it. Now jumping into our topic. All right, so what is the topic? Do you know what is the title of today's webinar, or what do you say? Let me hear at least one student knows. What is the name of today's seminar or webinar or talk or whatever it is? Your professors would have told you, yes or no? Name of today's seminar? Yes, no? Do you know about it? Maybe. Thank you, Shriya Reddy. A big round of applause to Shriya Reddy. The recent trends in grid and cloud computing. Before I start with my topic, this is my final question for you. Did you learn about grid and cloud computing in your course this semester? I repeat it. Whether you learned grid and cloud computing in your syllabus this semester. You can give me the answer yes or no. You can type Y or N. That's anything is fine for me. All right. Waiting for your answers. No, you haven't. So when you learn about parallel and distributed computing, that is the foundation. And then it came into cluster computing, then grid computing, now cloud, and mostly we now work on big data analytics. In today's talk, I'm just going to take about the real-time scenarios where the grid and cloud computing are used. Mostly students, they get confused. What is grid? What is cloud? Is it the same or is it different? All right. Okay. So, yes, ma'am.
I think he's having some problem with the keenness at the center.
Okay.
Can we shift on to the new?
Yes. Students, can you all click on the link that I'm posting on the chat? The YouTube link. I'm streaming the entire thing onto my channel. Just give a click on it. There you can give me your response in the live chat. I'm seeing students are getting increased. Yes, quickly join into from Zoom. You can join into the YouTube link. You can give your responses in the live chat. Once you join into the YouTube link, just type in your name so it will be easy for the teachers to take up their attendance. Can you hear me? One of you, can you unmute and speak whether whatever I said you're able to understand? Yes, good. Okay, just move into the YouTube link that I've shared in the chat box. There you can see my screen, you can see my audio, video. I will have your conversation in the live chat on the YouTube. I know because this pandemic made the students, the faculties, everybody digitally equipped. Thank you, Ahmad Khan. Yeah, we may shift from the Zoom. Yeah, yes, good. Vinay, you gave your attendance. Thank you. Arthan, thank you. Shashwant. Yes, Ayush. Yes. Okay. So you can give your attendance in the live chat and we could interact. Ma'am, students like 28, they've joined here and they're continuously joined. Okay. So furthermore, you can focus on into the YouTube link that I've shared with you. Okay. Let me, yes, as you said about the grid and cloud computing, Let's wait as the students they join in. You can make a note of my company's website, my email ID if you'd like to contact, and my mobile number. Yeah, students are building up in the YouTube. Yes, welcome Rohit. Welcome Dhanush. Yeah, Ronan. Yeah, Ashish. Okay, you're all joining. Okay, nice to see you all onto this YouTube link. So we will start the session. So before I start, most of you said you don't know about grid, you have not had it in your syllabus. Okay, so I started my talk like if it is parallel and distributed systems. All right, in the parallel distributed system, it's cluster computing, then it came on grid computing, and then it is cloud computing. Students, you're able to see my screen, right? So to start off with, what is grid computing? Okay, that question keeps bubbling, right? What is grid computing? Okay, it is like sharing the resource in an environment. Okay, it is sharing the resource in an environment. I'm going to ask you a question. Okay, how many of you have visited hotels to have food? Okay, how many of you have visited hotels to have food? Yes or no? Answers on the chat box, please. Yes? How many of you visited? Ma'am, your mic is on, ma'am. Dr. Vimala, ma'am. Okay. Let me leave this meeting and continue there. Okay. So how many of you visited hotels to have food? Yes, no, no, yes? Okay. Yes. So most of you, you're sharing a resource for a particular time. We don't own a hotel. Okay, the owner is different. Okay, the owner is different, but we go to the best hotel that we like according to our budget. We go, we share the resource in the environment, in the hotel. For a little while, we have the food and we leave it and come. Okay, so when we share a resource, okay, it is a common place. Okay, they categorized resources, that is the categorized menus they have. Okay, if you go to a vegetarian hotel, you get the veggie food. If you go to the non-vegetarian hotel, you get the non-veg food. If you go to Chinese, you get your Chinese. If you go to Italian, okay, whatever is a particular type of hotel that you visit on, okay, you will be getting the particular type of food. They have the resources and they're sharing the environment. So same way, when you want to work with high performance computing, okay, if you want to work with high performance computing uses, because some research centers or some universities will have a very good servers of high processing, like teraflops or petaflops or onto the high processing, but once they don't use it, it's not used. So grid, it is connecting. Understand? You're connecting it to the resources, and according to your time, according to your resources that you need, according to your time, you can utilize the processing capabilities. Okay, so it's basically grid computing comes under high performance computing. Okay, so resources, computers, data, instruments, storage, applications owned or administrated by some institution. When you're getting a collaboration with them, then you'll be able to use it. Okay, the resources are different places, but in order to accomplish our task, you'd be able to do it. Okay, it's basically used for data and compute intensive processing. Okay, when you have a large volume of data to be processed, because it cannot be processed in one single computer or a server that is available in an educational institution or any research center. If you're going to have a collaboration with the high performance computing, a different resource in the world, when we submit a job into the browser, it goes to the needed resources, computes a task, and you get it as a faster speed. Okay, the tools and applications, whatever that as a user applications, okay? The dictionary, the brokering, the diagnosis, or the collective services. Like, you know, when you want to buy a house or if you want to rent, you go to a broker or you see some websites, right? Where you can find where the houses are available, okay? So likewise, and you should know the resource and connectivity protocol are most secure. Okay, only if you are authorized, if you are authenticated, then you'll be able to get into it. The diverse resources, such as you can use whatever you need it. These are the different grid that is available, right? Okay, the CERN, if you see, it's an open lab for data grid application. If you want to work with the data intensive application, then you can get it. Has their own protocols to get grabbed into it. Okay, the data grid, okay, the data grid, the grid cat, okay, the grid lab, okay. So National Research Grid Initiative, the K grid, the data tag. Students, you can make a note of this grid and then you can Google it out and find out what kind of services or what kind of a resource these particular grids are having. Are they allowing you to share the resources with them? Okay, the open science grid, some of it or open source, where you also will get the access to the high performance computing servers or resources or whatever you need to use it according to your user requirements. All right. See, it's building national, this NEES is building the National Virtual Collaborative for Earthquake Engineering, okay? Detection of earthquakes. You know, in Philippines, we had a typhoon, a lot of disaster, Turkey, and they're detecting even Chennai or South India may also have some kind of attacks, but let's pray to God. Okay, these are all about the different grids. I hope students would have taken a note of it. Right now, seeing the simple definition of grid. Okay, it's an infrastructure that provides dependable, consistent, pervasive, and inexpensive access to high-end computational capabilities. Okay, so let's remember the hotel example I gave you. Hotel, if it depends, okay, what resources they have, only they will be able to provide it according to the menu card. The same thing is, it's an infrastructure that provides dependable, you can depend on it, it's consistent, it's pervasive and inexpensive, because you're not going to use it. If you own a hotel, the investment is large. You just go into a hotel, have some food and come back. Okay, you spend an amount onto it, but it's the amount is expense is less in comparison with investment made by the owner, but you get your needed services. Yes or no? Okay, you go to a best hotel or which hotel you like the most. Okay, like that, the infrastructure is provided, it's dependent, it's consistent, it's pervasive, but it is inexpensive. Okay, and you can get your high-end computation capabilities, right? The next one is a system that coordinates resources, not subject to centralized control. It is totally decentralized. In grid computing, if you take, it's totally decentralized using open general purpose protocol, and the security layer plays a vital role when you come to grid computing. Okay, so it's the ability to process information by utilizing collection of networked heterogeneous information processing components. It could be a hardware or it could be a software, all provisioned from various geographical location across the organizational boundaries. That's what I can't sit in India, but still I'll be able to access the resources, the computers or servers, in order to perform my high computing task that resides in US, in some country, or it could be in Europe, or it could be in Japan, it could be in China, or anywhere in the place. Okay, it is totally, the resources are totally decentralized. According to my requirements, I can submit a job, what I need. The brokering, we go and find out which place, which resource is available. Okay, then it will submit this job to the process. It computes, okay, it computes the needed task and gives me at the faster rate. Okay, the students, are you all with me, able to understand till what I've taken till now? Can I get an yes or no on the live chat, please? Quick. I know this time this pandemic made you all digitally trained and digitally equipped well. Okay, we were in Zoom. From Zoom, we moved into the YouTube live. In Zoom, I can ask you to unmute, but wherein I just want an answer on the live chat, please. All right. Yes, thank you, Amaravati Manasa. Okay, and grid computing, the concepts of ritual organization, rights. Okay, you all said when I started the session today, I asked whether you had online classes or offline classes this semester. You all said you had online classes. Even this grid computing, see, it came long time. Okay, the ritual organization. Okay, the key outcomes of this grid is open grid service architecture. Okay, and the Globus toolkit. Okay, so how they say how the grids are created, how they're maintained. Okay, how can you also interact with these resources? Okay, the Globus toolkit is a software middleware package. Okay, all that it's required, you need to install the Globus toolkit. Okay, GT6 or whatever the new kit that has come, and it provides a security approach. I told, right? Even the same example when I take into your hotel, they check you nowadays. If you go anywhere, what do they check? Okay, any place, you go to a hotel, you go to a shopping mall, you go anywhere else. Okay, now what is that you see at the entrance? What do they check you first? They check you. Yeah, answers on the chat, please. They check your temperature. All right, yes, they check your temperature and they provide some sanitizers, right? So likewise, they check the security, whether people don't have a temperature. Is it okay for us to let the people enter inside it? So even the Globus toolkit has got grid security approaches, which is the grid security infrastructure. It is implemented the Globus toolkit. It is developed by Argonne National Lab, University of Chicago, and ISI, University of Southern California. Students, you can make a note of this. Those who are watching it, globustoolkit.org. Good students, you're all giving your attendance on the live chat. It will be easy for your faculties. Globustoolkit.org is the website. Okay, so this is the website about the Globus. See, 10 years of connecting the research universe. Okay, so research data manipulated. Okay, you can transfer data, it's fast and it's secure, and see how much data, right? I don't know how to tell it. If it is hundreds, thousands, lakhs, it see every day. Can you see? Even live, the data is getting transferred. See how powerful are your data. So this is one platform. Maybe if anybody is interested to learn more at Grid and Cloud, you can contact me. Okay, here they are giving the entire thing. Okay, this is, you can have the resources. Okay, what are the supports? And what are the, okay, this is about the Globus toolkit which is run, and you can also transfer, you can share, you can use it for the purpose of grid computing. All right, the next that we are going to give, okay, so this is about the grid architecture. Starting itself, I said, you're right. Okay, how you have the user applications, then the brokerage diagnostics and monitoring, how secure it is, and diverse resources, whatever you want to access it. Okay, now jumping into the cloud. Okay, cloud is just a new name for grid. Nevertheless, yes, but problems, whatever we face in cloud computing, is same with grid, but they're not exactly the same. Okay, they're not exactly the same. The common need to manage infrastructures. I'm going to show you some 10 user real-time examples of grid and cloud, wherein you'll be able to understand how is grid computing working, how is cloud computing working, right? Okay, problems are the same. They need to manage the large facilities. Okay, I don't know how many of you have seen the Google's data center. Okay, the Google's data center is a massive data center where they maintain it. Okay, and because they've got a lot of resources. If you see the Facebook data center, okay, they have a lot of facilities that they provide. You have to define the method to discover, request, and user resources. Okay, when a user of a grid community, they want to submit a job into the grid, okay, you have a different research topics. Anybody research you want to do, you can think of, even for a final project, you can devise new algorithms. You can devise new algorithms to discover what are the services available. Or how do you, a request is coming and you have to discover whether the infrastructure is available, and mapping this request onto the services available at the point in order to successfully complete the task. Because you need resources for different kind of requests. There are different kind of resources that is needed. So this discovery mechanism, that is the brokering, should able to find out exactly whether when I'm going to fit this job onto this process, whether it's going to complete it on time, especially for implementing high parallel computations. Okay, it reduces. I told you the example of the hotel that we go and eat it, right? The owners, okay, the owner's investment is more, but we go for a limited time, get into it, have a food, we pay for it, and we come back. But still, we are using the entire infrastructure, we're using their resources, we're getting their services. Okay, everything we done it. Okay, reduces the cost of. Imagine if you invest in buying. Google has invested a lot to buy the data center, but we are just utilizing the resources, right? And reduces the cost of computing. Okay, if you want to generally mainly work with high performance computing, then according to applications, could be grid or cloud. It increases the reliability. Okay, you can rely on the services because it is like 24/7, 365 days. It is available. It is maintained, but only according to a needed thing we need. And also, it increases the flexibility. Okay, so great increased demand for computing. Do you remember when I started my talk, I spoke about the cloud cluster computing. First we had parallel and distributed, then came the cluster computing, then there came the grid computing, and then it's the cloud computing. All right, okay, so billions of dollars are spent by Amazon, Google, Microsoft to create a real commercial large-scale system with hundreds of thousands of computers. Okay, so you can see how much is the data. It's the top 500.org. Okay, it analyzes massive data. Okay, so you're all using Facebook. Imagine how much data are there in our Google Drive. We don't have any physical drive. It is all stored in the Google's data center. Okay, we load a lot of photos into the Facebook, right? We load the photos into the Facebook. Okay, and even it gives us the memory. Okay, last year this time you were in this place and this, so much and so more. All right, and how many of you, what is the data space given by Google Drive for a normal Google suite normal Google user? Can I get a response in the chat, please? What is the size? What is the size? Yeah. What is the data size that it is giving? Yes, no, yes. Yeah, 15 GB. We don't invest, we are not buying it. Okay, we are not buying it, but still we are utilizing the resources. Okay, it analyzes massive data. So when we come to cloud computing, okay, with the resource management in grid, it is batch schedule. It's like queuing. Okay, you have, when you go to buy a ticket nowadays, I don't know, most of us, we buy it online, but now when you go to physical shop to buy some groceries, now people are asking us to wait on a queue. One goes, gets in, and because of the social distancing and other factors of this new normal, right? So it is batch scheduled. Okay, cloud, the resources are shared by all users at the same time. So now listen carefully. Now when we are finding the difference between the grid and cloud computing. In grid, I need to submit the job. Then the service discovery happens, finds the resources, alerts the job, according to the resource available and whatever it is request. It involves a queuing mechanism. Okay, but cloud resources are shared to all the users at the same time, in contrast to dedicated resources in the queuing system. Is it clear? Okay, so the one of the services that is more challenging is the quality of service. Okay, all of them are accessing at the same time. Okay, the best example, it could be the result publications. Okay, when all of you are going to hit the server on the same time, okay, if the cloud is being distributed or if it is loaded onto one server, then it's the quality of services makes a vital role in cloud. But understand clearly, in grid it is a queuing mechanism, but in cloud computing it is fully, everybody can access it at the same time. All right, the data model. So grid, the grid was the first which brought on the concept of virtual data, replication, metadata, catalogs, everything, structured representation. But to achieve, okay, to achieve good data, it must be distributed over many computers. When it comes to cloud computing, okay, we have come across a concept of map reduce mechanisms. Like in Google, they use the map reduce mechanisms. I don't know how many of you, anybody has heard about map reducing technique? Yes or no? Can I have your answers on the live chat, please? Okay, so grid relies on NFS, okay, NFS, GPFS, the virtual file system, but Google Cloud, it is on a map reduce mechanism. It could be on a Hadoop distributed file system. Yes, no, no, yes. Anybody heard about map reducing mechanisms? Because Google has got the most data, right? When you see Google, when you click on the 9 dots, lots and lots of services Google is providing. All right. Anybody heard about the MapReduce? Yes, no, no, yes. You're mapping onto a task and reducing it. Okay, I can show you. Okay, this is about the top 500.org. Okay, you can see to it how the top news about the high performance computing. Okay, on September 1st. Okay, high efficient system solutions for that makes sense. Data is the center of the society, and a lot of good latest updates about the high performance computing you will get from this. Make a note of it. Top500.org. Okay. So about the different companies, okay. So just I would like to share this with you. All right. So when you have your, I've just installed the Hadoop. This is the Hadoop distributed file system. You need to have the set of steps, okay, set of steps, okay, set of steps to run the Hadoop. This is, in this example, I'm just running the Hadoop distributed file system on my local system. Then what is the system that I'm just using? A MacBook Air. I've just installed in it. So what is the GB that it is providing? Okay, so what is the distributed file system, non-distributed file system? Okay, all the data is about the we have a name node, we have. So once I install and run it, okay, I have my name node, that's a master's node. Okay, I'll just make it a little bigger for you to see. Okay, so on this port number, the node manager runs, the main function runs, the secondary name node. Okay, we have one name node and one data node in this, but if you're going to use for a different sets, you have a name node and different data nodes. Okay, and the resource manager, I told it has to manage the resources and the GPS. Okay, when a job is submitted into Hadoop, okay, it goes and finds out, okay, what are the data nodes that is available. It executes the task and you get back your results, right? And you get back your results. So Here in big data analytics, basically most of them they use a Hadoop distributed file system. Okay, where you because in Hadoop, even on a normal local system, I have worked even with 10 lakhs of data, and I was able to get my answers within microseconds. Okay, so I'm going to just show you an example of like Uber 2. Okay, I'm just can you see I've written this program? Okay, Uber 2. You have to write a mapper program. Okay, I'll just check whether I could be able to increase the size. All right. So nowadays, here I've written a program on a mapper, then and the reducer tasks runs. Okay, mapper and a reducer. So mapper, I'm mapping my task, okay, and reducing it. Say for example, my job is to find, okay, how many words that repeats. Okay, the word count. That's a basic example that I could take. So I map all my text onto my mapper. Then it will split into different each and every word. It will extract the word, and then it will count how many number of words are repeated, and I will get my reduced result. Okay, if I'm going to say hello, how are you? Hello, I am fine, which means hello is repeated twice. It will reduce into hello, comma 2, and whatever the different words that is available. It works the concept of mapping a task onto a resource. You can take this example when you go to your exam hall. Okay, when you go to your exam hall to take up your exams, okay, your faculties, they will come with a set of name list who are allotted to the room. Okay, once when you enter into your classroom for to take up your exam, say for example, in a classroom like 20 students are being allotted. Okay, in a classroom where the 20 students are being allotted, the faculty who is going to invigilate will have the name list of 20, right? So then they check it out. Okay, then they check out their names with your hall ticket and will find whether you are, and then they'll give you to the seat that is allotted. So mapping the task. After that, they will distribute the question papers to you. After you get your question paper, you take up your test. Okay, you take up your test. So your teacher is your name node, and the students, those who are into the classroom, are the data node. Okay, once the class is 10 o'clock, the teacher will say, yes, start your exams. Okay, the teachers will say, yes, start your exam. Then you start your process. That is the job that you're executing it. Okay, the mapper is allotting the task onto the different reduces. You know, it is 3 hours, whatever it is. Your brain, for yourself, right? Whatever you have learned, if the question is fast, then you start writing it. Once you complete your exam, maybe if it is a 3-hour exam, you complete it, and you submit the papers to the teacher. The teacher will reduce it by organizing it according to your register number. Is the concept of mapping and reducing being clear? Okay, are you able to understand about mapper and reducer? Can I get your answers in the chat box, please? And a lot of students are viewing it through the chat box, through the YouTube live. Okay, since we will not be able to communicate with you through audio, it's better to communicate through the live chat. Anything is fine. Able to understand the example of how the teacher is allocating the place to the students onto the particular room where she is invigilating, giving you the question paper. After you take up the task, she gets the answer sheets from you, and she reduces it and give it back to the controller of exam. Can I have your responses, VIT students? Yes or no? I know you are all smart, energetic students. Let me have an answer. If you find typing as is difficult, just type a Y, or if you're not able to understand, you can type it as no. Yes, no? Okay, let me wait for your answers. Before which, I'm going to just show you a demo of, see, I have this Uber. Okay, it's a file. Okay, it's a file. Like, you know what Uber does, right? You know, how many of you have traveled in Uber? Yes or no? Responses, please, on the chat. Okay. So here it is a batch number, the date, how much he has traveled, okay, for a particular driver. All these data are being given, okay. So how much kilometer he has traveled, whether he has done, okay, from which I am going to compute a task using my mappers, okay, because it is all done using the comma. I'm separating it using the comma. I'm finding which day, from the date I'm going to find which day the Uber has provided. No, by this pandemic, I can understand Ola, Uber, and all. You all, yeah. Yes, thank you, Mrutala Menon. You're able to understand. Thank you for your response. All right, okay. Then. So you're going to find now there is Ola, Uber not running much because of this pandemic, but this was data set was taken a little before, all right, and when it was all moving very well, and then you're going to find which day they had the maximum number of trips. So I have uploaded the data what I show you. I'll just browse my Hadoop file system. Yeah, it's Uber. Okay, it's Uber. Can you see this location? I have this data set. Okay, I have loaded into my Hadoop, because when you have your file system in your normal thing, it doesn't work. Only if it is there on your Hadoop system, you'll be able to run. And so this is my data set. Okay, this is my data set. I've uploaded onto my Hadoop system. Okay, now going into a terminal. Okay. Okay. So here I'm going to use I've created a jar file. Okay, I'm going to give Hadoop jar uber2.jar. Okay, where is the jar? And I'm going to give a new file as this is my input file. I showed you, right? So whenever I use Hadoop, it goes into my Hadoop file system. It doesn't depend on the file system that is available here. It goes to the other file system. All right, uber2 jar, my input and my output. I'm going to give 91, OP091. Let me show once it runs. So it is running. It is running on the concept of mapping and reducers. Okay, so it scheduled the metrics, the job tracker. Yes, it is running now. Yeah, it is done with all the types of mapping. So 354 mapping inputs, the outputs. Okay, how many it is combined? Okay, combined outputs. Okay, it's 42, and it is reducing it because I told you I've given the dates and how much trip the particular driver has taken. From the date, if you could see the dates on a particular date is so many. Okay, so on if I take 1/1/2015, I don't know. So these many rows, it has to find out the sum of these on a particular day and every Sunday that it comes and every Monday. Let me see whether we have received the output. It is, I think I gave OP091. Okay. Let me check whether yeah, I got it. See, today is November 6th and the time is 9:48. Okay, 9:48. We received it, and this is my output. And I'll get whether it is success, and I'm going to click on the part or 001. I'm going to download it because it is on a Hadoop system. I need to download it and view it. Let me view it. So from the data sets I've given, okay, can you see now it has been reduced on which date for this particular batch for according to that for the particular driver. So if I see 2512, I can see on Thursday, oh, no, on Friday he has got the maximum trips. All right, and for this person, and with this analytics 2598, I can figure it out. It is on Friday. So almost on Fridays, the number of trips are more. Then Uber will give you some discounts or some kind of analysis they do. Okay, they do a lot of analysis, the big data analytics. This is an example of how it is used in the Hadoop distributed. I just showed you an example of map and reducer using Hadoop. All right, and then Virtualization, yeah. Cloud, it's totally, you know, right? I took a data set which is not on my system. I put it onto my Hadoop. So a lot of virtualization. Cloud entirely depends on virtualization, but grid, it does not depend on your virtualization, right? Okay. So these are different projects available. Okay, National Research Grid Initiative. This contains like 3,000 CPUs. Imagine 17 teraflops of processing offered by various research institutions throughout Japan. Okay, and you can make a note of it. NAREGI, the grid project. Okay, and the next is VOINC. It's an open source for volunteer computing and grid computing. I advise the students, you can find it out. They use it for Bionic. They use it for climate predictions.net, ACTI, because for climate predictions you need huge volumes of data to predict your climate, right? Okay, neither cloud or grid, they don't have a common defined definitions. Okay, so grid, it's publicly funded and it's operated, but cloud, it is privately funded and it's operated. You are using every sources of the Facebook, Google, everything. Even now I'm streaming it on YouTube, right? I don't have any infrastructure, I don't have anything, just I'm streaming it through YouTube Live provided by the services. Okay, grid and cloud computing are instance of distributed system. Okay, so the basic is the parallel and distributed system, and it involves slowly, and grid evolves slowly, but cloud very fast. Okay, is significantly lower. If you want to become an expert in cloud, anybody can make it, but grid you need. Okay, when you see some live examples, I just tell you quickly, because as we are going to, yes, we'll be seeing it out. I know you students, VIT, Vellore, okay, the School of Computer Science, you have got the next classes going on. I'll just tell you what are the live examples. If you have a note or pen with you, quickly make a note of it after the session. I want all the students or the viewers who are watching through YouTube to just go through it. It's live examples, whatever is available. ACTI, which is the search for extraterrestrial intelligence, okay, and it's a scientific that is uses internet connected computers. Okay, so you can run your free program and analyze radio telescope data. Okay, if you're interested to work on with, you can run your free program. I told about Bonic, right? So Berkeley Open Infrastructure for Network Computing, it is developed by the University of California, okay, for doing research and all in scientific areas. This is basically used, and Bonic was developed to support ACTI, and also it is used for mathematics, medicines, molecular biology, climatology, and astrophysics. And the next, the third one is Folding at Home, FAH. Okay, it's a distributed computing project. Okay, just make a note of it, and then you can also know it. And my YouTube link will be always fine. You can also come for protein folding. Okay, for biophysics it is used, Folding at Home. And the next project of grid is Einstein at Home, is that uses computers idle time to search for spinning neutron stars called pulses using data from LIGO gravitational waves. So sometimes we don't use, when we sleep, we shut down a system, that resources also can be taken, and it is used in Pyrotechnico. Okay, the next example is GIMPS, Great Internet Machine Prime Search. Okay, it was formed in 1996. Okay, thousands of small computers like you to search for these needles in a haystack. Okay, LHC is a volunteer computing program which enables to contribute an ideal time of this computing system. Say, for example, if you are in your college, only the college time you use your lot of computers. I know I visited your university, right? I did a lot of computers. When it is not used, it can be used for help assist develop and export particle acceleration such as CERN. Okay, LHC at home. But you need to tie it up with them. The World Community Grid, okay, is to create the public community of grid. Okay, I told it is public, and cloud is private, you remember. Okay, for human genome, HIV, dengue, and different things. Now I'll quickly tell about the 10 real world examples of cloud services. After this, I'll ask you, we'll have like a small QA session if you have got doubts. Okay, we'll be sharing it. Okay, you'll get a feedback in the chat bots that you use. How many of you are using Alexa or Siri or Google Assistant? Yes, no? Siri, hey Siri, do you love me? Oh my God, my Siri got a vent. Whenever we say, hey Siri, it gets opened. Yes, you're using it. Okay, the chat bots. Okay, this all runs on a cloud. For an example, I said, hey Siri, my Siri got open and I was asking what. All right. So next is, I know most of you are using Google Docs. Okay, if I'm going to whenever you use your Google Drive, a lot of resources, okay, a lot of resources you have. You are not buying a Microsoft version of it, but they are providing as a service, the Google Docs. Okay, this is the Google Docs. Okay, the Google Sheets, the Google Slides. I use my network notebooks, the Colab notebooks. Okay, everything, the Colab, they provide you the services of TPUs, and I can run whatever I need to run. All right. So the productivity, okay, the cloud computing, okay, working on a presentation, that is the Google Slides, the spreadsheets, the Google Sheets, okay. I know anybody is using Google Slides, Google Sheets, Google Docs. Yes, no, no, yes. Answers on live chat. Do not worry, students. You will definitely get the feedback. The teachers are always with you. And you have also given your attendance on the live chat. It will be permanent. Okay. So give your response. All right. So here, and also Netflix. I know most of you are using Netflix. This pandemic, yes, watching movies, right? That runs on the cloud. That runs on the cloud. Okay, you are not going and buying it, only you are using the services that you need. And I know if I ask this answer, everybody will type this. How many of you are using WhatsApp? Definitely yes. Instagrams, okay, Instagrams, Skype. Now we are using the YouTube Live to have some kind of communication, right? So that's it. Okay, these are all running on cloud. Okay, these are all running on cloud. Google Meet. I think more than the live traffic, the network traffic became so big during this pandemic from March. Okay, because everybody online classes, online, this, that, online meeting, online webinars. You can check out in my company's website. I think more than 45 to 50 webinars I could have done during this pandemic, right? So, and backup and recovery, okay, as I said about Google Drive, Dropboxes are the best examples of cloud backup solutions. All right, and then we move on to the business applications. Now, before which we have to buy some product, install in our organization, only that we can do. Now it's like a lot of CRM, ERP, okay, it's all based on cloud. They're providing software as a services. You have to just log into it, utilize it. So the best example is the Gmail that you use, okay, HubSpot, Keto, okay, or they are all providing. And Blaze Meter and Loadstorm, as we are not having much time, you can just make a note of it. Blaze Meter and Loadstorm, okay, they're popular testing tools, okay, that runs on cloud. That is what I want to emphasize on that, right? And a lot of application developments while designing. I know most of you will be playing some games or you using an applications, right? If I take my mobile, I have a lot of applications like Google Doc, Google Slides, okay, Google Sheets, like applications like Instagram, Twitter, LinkedIn, okay, and Facebook, and so many applications. So all these applications, I'm not owning anything, just every application that is running on cloud, okay, and it's cross platform. Amazon, okay, this I want to just show it to you, okay, this one, because you're all students. Some of you will be interested in or I say, yeah, this is that. I'm just going to complete now. Okay, this is free, powerful, fully customized. Okay, okay, if you are a game developer, try using Amazon Leopard. Yeah, okay, so you can create a fan base, you can build it for free, you can build it more. They're giving you tutorials, and they're also providing free training, and they're giving some samples how the mobile games, okay, the development, they have done it. So students, kindly grab this opportunity, do not leave it out. All right, and this is about Amazon Lumberyard. And for, as I said, before it's of the Twitter, the Facebook, the LinkedIn, everything that you use, it is relying on the cloud computing services, right? So, and I told you about big data analytics, Hadoop. Okay, I showed you about Hadoop, right? The distributed file system and how I'm loading it, how I'm uploading it, all right, and how it is getting transferred without cloud computing, real data. I took a real data of Uber, okay, trip, and we have worked on with that. So cloud services, you make everything at home, or there is an infrastructure as a service, you take and bake, okay, everything will be there, okay. Vendor manages the pizza dough, the tomato sauce topping and cheese, you have to check whether it is oven, you have to fire it, or whatever you need, you can take it and bake it and eat. And next is platform as a service, the pizza delivery, they come, they're providing the platform as a service, dining table and soda, you manage it, but everything they provide it, okay. And the last is software as a service, you go out about dining, finish it, and then come back. All right, so any questions? So I know it is time for your next class, students. Hopefully you should have understood what we have discussed today, okay. So we started with normal grid computing, cloud computing, what are the recent trends that is going on. Then I showed you an example of Hadoop, distributed file system, how to take an analytics on different days for a particular driver, which day he has got the maximum trips. All right. So on my screen, you can check out my mobile number, my mail ID, my website. And if you are interested to get more details about Grid and Cloud, feel free to contact me. Thank you, Harshal. Any questions you have, you can put on your chat. We are going to, I've come to the end of my presentation. I just quickly went through about Grid Cloud, the differences, and 10 real-time examples, and I just showed you an running off of a MapReducer example of Uber driver analysis, which day he had the maximum trip. Any questions? Okay. You can just post any questions you have. You can post it on the live chat. Thank you, Vishnu. Welcome. You can give your feedbacks. Is it time for the students? Yes, ma'am. How do you interact with you, ma'am? Okay. Your audio will be here. Your audio will be here now. I will share a link to you. I will share a link to you. Can you just come on to the link? I'll just share a link to your number now. Can you just join in? I will share a link to you, ma'am. Can you just join into the link? Okay. So thank you, students, and I will be, yeah, just a minute, your ma'am will come online. So, or thank you, Roshan. So any other doubts you can ask? You can ask your doubts on the chat. I'd be able to answer to you. Yes, please. Any questions about Grid Cloud? And wait for some time. So, how do you find the session? Thank you, Pranav. You'll give a good feedback. It was insightful. Thank you, Gopinath. Thank you, Reese deserves. Thank you, Dr. Vimala Devi, ma'am. She'll be joining soon. I hope it should be useful. Thank you, Vishnu. Harshal. Thank you, Dency, ma'am. Happy to see you back again. Yeah, more than one set of students are here. So you could take up the best insights that you need. Always feel free to get, yeah, your ma'am has come.
Yes, ma'am.
Ma'am, can you speak? Yeah, students can meet you and they could also speak with you. They can hear you. I can see you on the live.
Yes, ma'am. Ayo.
Yes, I can
Hello.
hear you, ma'am.
Agree.
Yes,
Okay,
ma'am.
ma'am. Thank you, ma'am. Really, it was very interesting. And they don't have a grid and cloud computing in their syllabus as of now. They're doing only parallel programming using OpenMP and MPI. So this is the next level, next trend they are learning, learning to going towards the trends in parallel and distributed computing, taking as grid and cloud computing. You have given a nice session, ma'am. It was really wonderful and interesting, and it will be really useful for the students also. I thank you for spending your valuable time with us. Really, I thank you for your support. I need your continuous support also in future also, ma'am. Thank you, ma'am.
Sure. Thank you.
Thank you.
Thank you so
Thank
much
you,
for
ma'am.
the invite from VIT. Yeah, we are always here to render our services. Thank you, ma'am, and God
Thank
bless.
you, ma'am.
We are
Thank
signing
you.
off. Bye-bye.
Bye, ma'am. We'll wind up the session, ma'am. Thank you, ma'am.
Yeah.
Okay.